Hello dear students, I welcome you all in my lecture on operator overloading. Starting with the purpose we need to overload the operators. Just to simplify in a single line, we can say that we want operators to work for our user-defined classes. We can overload most of the operators which are available in C++. In computer programming, operator overloading, sometimes termed as operator ad hoc polymorphism, it is a specific case of polymorphism where different operators have different implementations depending on their arguments and our programming needs. Operator overloading is an important concept in C++. It is a type of polymorphism in which an operator is overloaded to give user-defined meaning to it. For example, a plus operator can be overloaded to perform additions on various data types such as integers, floats, and we also want the same operator to work with our own user-defined data type or simple R objects. So it is used to perform the operations on the user-defined data types. In C++, we can make operators to work for user-defined classes. This means that C++ has the ability to provide the operators with a special meaning for a data type. This ability is known as operator overloading. Moving towards the syntax of the operator overloading, these are just defined similar like a function. The operator is normally defined just like we are going to define the function. The difference between a function call and the operator call is that whenever we are going to call the function, it is always called with the reference of an object, and we use the dot operator for that. We also use to pass arguments within the round brackets. On the other hand, whenever we are going to call an operator, we are just going to use the symbol of that operator, and we are not going to use any dot or reference operator to call a specific operator. So that is the main difference between the operator call and the function call. Although whatever work that we want to perform using the operator can be easily done using a function as well. So now moving towards the syntax, similar like the function has a name, then has a return type and an argument. Similarly, the operator, as I've told you, that it is similar to a function. So we are going to have the return type. The return type mainly means the type of value that the operator will going to return us. Then we have the keyword operator, and then we are going to provide the symbol of the operator that we want to overload, and then in the round brackets we are going to give the arguments. For example, I'm going to overload the plus operator, so I'm going to write operator, that's the keyword, and then the symbol plus. I'm going to overload the plus operator, and this particular overloading signature will not going to return any value, neither it will going to accept any values. So this is basically the syntax through which we can use to define an operator when we use the operator overloading. Okay, the operators that we cannot overload are the scope operator, because it is reserved to reference a class. We cannot overload the size of operator. Similarly, we cannot overload the dot operator, that is the axis operator. We cannot overload the pointer operator, and similarly we cannot overload the ternary operator, that is also known as the conditional operator. Because all of these operators have some specific functionalities, and the programmer cannot change these functionalities. Rules for the operating overloading. Remember that we can only overload the built-in operators. We cannot create a new one. We cannot create our own operator. We can only overload the functionality of any built-in operator. Second rule, that the order and the precedence of the operators cannot be changed. Fourth, the operator cannot be overloaded for the built-in types only, which means at least one of the operands should be of user-defined type. That means we need to pass at least one object of R type. R type mainly means the class that we have defined. Assignment operators, subscript operators, function calls, member selectors, and the operators must be defined as a member function. We cannot define these operators as friend. The last point explains that except the operator is specified in above, we can overload any operator that is available. So we are going to overload any operator except the previous operators that we have defined, these one. We cannot overload these operators plus the operators that are defined in point number 5. These are the operators that cannot be accessed using a friend function. Except these, you can create either a member function or a friend function. Generally, I recommend my students to work with the member functions only, just to make your code simplify, which means that whenever you want to overload a function, you can make that function as a member function rather than creating a friend function. Two types of operators are available. Either we have a unary operators or we have the binary operators. Unary operators are the operators which work with only one operand, which means one data type. And the binary operators, as the name suggests, it works with two operands, which means two data types. For example, plus can be used as a unary operator. In the example here, we have used plus and minus with a single data element like plus a and minus b. In the another example, we have used a plus b. So if you refer to the first example, you can see we have used the plus operator and apply simple one operand. And in the binary operator, we have used plus as a binary operator, which means it will going to work on two data members, that is a and b. So we can work with the operators in a unary form, or we can use the operator to perform some binary operations. So this is an example that shows us the implementation of the unary operator. We have created a class unary example, that is example, in which we have declared one simple integer number. Then in the public area, we had add a constructor that will going to initialize the local variable within value 8. And now look, we have going to define the operator. You simply write operator plus, which means I'm going to overload this plus operator in my class. It will not going to return me anything. It will not going to accept anything. And what we are going to do, we are going to increment the attribute value by 2. And then we have also add a print function that will simply going to print the values for my local variables. In the main, we have created an object t, and then we have called the operator like plus t, and then we have called the function t dot print. So you can see when we are using plus t, which means the operator is called, so it will going to increment the value of my local variable, that is num, and the value will be changed from 8 to 10, which means 2 will be added. And when you call t dot print, you will see that it will going to print 10 on your screen. So if you refer at this particular point, when we had made two calls, the first call is my operator call at this point, and the second one is my function call, that is t dot print. So at this point, when we have called plus t, you can see that no dot operator is being used and t is explicitly passed to this function, that is plus, where in the second line t dot print right here we have used t dot print because print is a function and it is called using a dot operator. So this is basically the difference between calling a function and an operator. Okay, so this would be your output, that would be 10. Now remember that when the unary operators are overloaded through a member function, it will not going to take any argument because we are not passing any value. We are simply using one data variable, and if you are using a friend function, it will going to take one argument. This is basically the specific case of the unary operator. Okay, moving towards the binary operator, this is one of the example in which we have implemented the binary operator plus, and now I'm going to again create a new class, that is b example, which means the binary example. Similar to the previous class, we have included one simple data member, that is integer num, and in the public area we had added a constructor that will going to initialize my attribute by value 8. Now I'm going to use the plus operator as a binary operator, so that now it will going to accept an argument of type integer, which means at the runtime I can add any constant value to the private data member of my class. Now the operator will not going to return anything, and it will going to accept one integer as an argument. The operator I'm going to use will is plus, and the before the plus sign I'm going to add the keyword operator. And similarly, whatever data is passed, it will be added to the value of my local variable num. Then we have a print function that will simply going to print the value on my screen. Okay, similarly, we have created main, and in the main we are going to now create an object of my binary example, that is t, and now look, I'm calling t plus 10. So now I'm going to pass two objects or two operands. First operand is t and the second operand is 10, and you can see that I have written t plus 10. So this is basically equal to t. Basically the plus operator has been called on the reference of t, therefore t will be automatically passed to the function, and then as an argument I'm going to call this 10. Similarly, this is something like this, that I have called a function that is plus, so I'm going to call something like t plus t dot plus, and we're going to pass this 10 to as an argument, and this argument will be passed at this place, and whatever value I have passed will be going to add it in my local variable. Then I have called t dot print to see what it will going to print, and you can experience that it will going to print 18 because I have passed 10 as an argument. I have called t plus 10, which means add 10 in object t. So the object contain only one variable that I've mentioned here in the operator. Therefore, it will going to add value 10 in the previous value of my local variable, that is 8. So it will going to print me 18. Another way of writing the same operator is that we can use something like this. Now I'm going to pass an object of type binary example in place of the integer. Look, in the previous example we had passed one integer value, and now in the second example we are passing an object as an argument, which means now this plus operator can easily work on my objects, and now I'm able to add two objects. Let us see the main code. In the main we have created two objects, t1 and t2, and then I'm going to write like t1 plus t2. It's a small typographic mistake. This is t1 plus t2. So I'm going to call this like, I'm going to call t1 plus t2. So when I'm going to call this function will be called, this t1 is basically passed explicitly because this plus operator is being called with the reference of t1, so the t1 is available. We can also use this dot num to access the local variable of t1, and t2 similarly is passed as an argument. So this t2 is been passed to this function, and it will be hold using local variable, that is e. So this basically will going to be held by e, and then I'm going to write the statement like this dot num plus e dot num. So this num is basically representing t1 dot num because this plus operator has been called with the reference of t1, and t2 is now being held by local variable e. So we've written e dot num, and the result will be stored in num, that means t1 dot num. So the result will be held by the first operand, and then we are going to print t1 dot print. Again, it's a typo mistake. This is basically t1, so we are going to print t1 dot print, and you can see that the answer would be 16 because the constructor has initialized both the objects with the value 8, and when we have called this plus operator, it will going to add both the values, and the result will be stored in the first operand. But what if I want to return some value and it's stored value in some another variable? Then we can use this particular code. Now I have changed the implementation, the same function, but now it's going to return me an object as well. So I'm going to hold my data in this particular variable, that is num, and then return this num from out of this particular function. But now you can see that the type of num is basically what? It is basically a integer. And what I'm going to return, I'm going to return an object of type b example. Okay, just look at in the main, I have created c1, c2 and c3, and then I have simply written c1 is equal to c2 plus c3, which means that the addition of the data of c2 will be added with the data of c3, and it will going to return me an object, which means that there's a little error in this particular code. So are you able to identify and correct this code? I hope yes, you will. So how I'm going to write? So the code would be like, I'm going to return an object that is of type binary example, and this is my operator plus, and I'm going to accept a simple like temporary variable e. And look, always remember, whenever you want to return an object from any operator, we always need to create a temporary object. Like, for example, I'm going to create a temporary object of type B example, like ret. This is my object, and then I'm going to perform the exact task like ret dot num, which means the variable that is created or holded by the object ret, that is a temporary variable, is equal to num. And what is this num? This num is c2, this one c2, and I'm going to plus e dot num, and then I'm going to return ret from my function, and this will be over. So this is how we are going to write a code where we are going to overload an operator such that it will going to accept an object of my type, and then it will also going to return me an object of my type. Therefore the statement in main should look like something like this, like c1 is equal to c2 plus c3, c2 plus c3, which means that this plus operator has been called with the reference of c2. Therefore we can easily access the variable like this dot num will refer to c2, plus we have c3 that is held by e, so e dot num will represent c3, and then the submission of these two integers value will be holded in ret dot num. This ret is my temporary object that I'm going to return from this particular operator, and at the end I'm going to return this object. So this is how we are going to write a code for operator overloading when using this operator as a binary operator. So similarly, you can override any operator that you want. It can be assignment operators. These can be arithmetic operators. It can be arithmetic assignment operators, relational operators, logical operators. So you are free to use and you are free to overload any operator except five, which we have discussed in our previous slides. So you can easily overload any of these operators, and the operator will be changed, and similarly the code will remain same, and you can perform any particular task that you want to perform. Okay, rules to be remember in let me clear the screen first so you can easily view. Yes, so rules to remember while working with the binary operators. Always remember, whenever you are using the operator overloading function as a member function, you just need to pass a single argument. And if you are trying to overload a function, the operator using friend function, you need to pass two arguments. So this is basically the rule that you need to remember. I hope this will going to help you in understanding the concept of operator overloading. Let us move towards the summarization of this lecture. Remember, we can overload any operator except the dot operator, the pointer operator, the address resolution operator, size of n, the conditional operator, that is also known as the ternary operator. It can be a member function, it can be a friend function. Any one operand must be a user defined type. It is mandatory whenever we are going to overload the operator. Always remember that whenever we are overloading the operator, it is mandatory to pass or to use any one operand that is of user defined type. I hope all these points are clear to you, and the lecture will going to help you in understanding the concept of operator overloading. So thank you and goodbye.